Hello there, you are welcome. In this video, we're going to be solving this question. We want to find the value of x from this equation. 27 raised to power x minus 3 raised to power x is equal to the square root of 27. Now, real quick, we're going to express 27 as a power of 3 because of this 3 that we have here. So let's express 27 as 3 raised to power 3 because 3 raised to power 3 is 3 times 3 times 3, which is 27. So let's put the exponent of x as we have there. And then minus 3 raised to power x is equal to the square root of 12. Okay, moving on. Do you know that this 3 raised to power x, the one here, can be interchanged because they are commutative? Multiplication is commutative. So if you have 4, let's say times 5, this can be expressed as 5 times 4 and you will get the same result. So the reason I'm doing that is to have a common term like we have here, 3 raised to power x. Yeah, so we're going to do something with that. Let's move on. Now this is going to be expressed as 3 raised to power x and then times 3, then minus 3 raised to power x is equal to the square root of 12. As you can see, we have 3 raised to power x here and we have 3 raised to power x here, the same. We are going to make y to be equal to 3 raised to power x. So I can say let y be equal to 3 raised to power x. The reason for doing this is to simplify the equation. We do not want so many exponential terms. We just want to remove those large terms and make them simplify so it will be easy for us to solve. Now, since we are making y to be equal to 3 raised to power x, it's now going to be y raised to power 3. Now notice 3 raised to power x is y. So then you have minus, what's now 3 raised to power x? That's going to be what? Y. And then it's equal to the square root of 12. We have a little problem. What is that? Square root of 12. We don't want this radical there. So we're going to square both sides so that we can get rid of the square root symbol here. So let's apply the square to both sides. Rather, if you square both sides, the square will get rid of the square root. So you have 12, which is a whole number. Now, let us expand y raised to power 3 minus y all raised to power 2. From algebraic identities, if you have a minus b all squared, this can be quickly expressed as what? A squared minus 2ab plus b squared. If you expand this, you're going to get this. Okay? So let's come back to this. You see, we can compare this and this. They compare greatly. If you compare this now, you see that a is y cubed and b is what? Y. So I'm going to say here, let a be y cubed and then let b be what? Y. So I'll just use this to expand this y cubed minus y all raised to power 2. Okay, so now if we put that together, y cubed minus y all squared will now be equal to, remember we said a is equal to what? Y cubed. So that's going to be coming here. Now look at this, y squared. So it's going to be y cubed all squared. Remember a is y cubed. So coming, this is minus 2ab minus 2. A is what? Y cubed. So times y cubed. And what is b? B is what? Y. So write y here. Then plus b squared. Since b is y, I'm going to write y squared here. So let's wrap this together and let's make everything wholesome. So y cubed all raised to power 2 can be further simplified to y raised to power 6. 3 times 2 is 6. That's how I got 6 there. Then minus, what about, there's a power of 1 here. Yeah. So from the laws of indices, from one of the laws of indices, they have a common base of y. You can just add the exponent. So this is going to be 2y raised to power what? 3 plus 1 is what? 4. So that's going to be 4 and then plus y squared. Okay, and this is equal to, remember we have something on the right hand side. What is that again? It is the square root of 12. The square root of 12. Remember we have squared both sides, so we no longer have the square root of 12. We now have what? 12, as you can see here. So let's go back and write 12 on the right hand side. So 12 is here. So let's move 12 to the left hand side. Let's move 12 to the left hand side. So you're going to have y raised to power 6 minus 2y raised to power 4 plus y squared minus 12. If you transpose 12 to the left hand side, you get minus 12, and all is equal to what? 0. What are we going to do next from here? Interesting question. Now, I want you to observe this. How many terms do we have on the left hand side? We have this one, 1, 2, 3, and 4. So for us to be able to factorize in twos in such a way that we are going to have a common factor in each of the factorization, if you understand what I mean, we need to have 6 terms. So how am I going to do that? Let me show you something. I can rewrite minus 2y raised to the power 4. See, minus 2y raised to the power 4 can be rewritten as what? Minus 3y raised to the power 4 plus y raised to the power 4. If you add these two terms, you are going to get minus 2y raised to the power 4. Remember, I'm trying to make them become 6 terms. So I'm splitting minus 2y raised to the power 4 into 2 terms. Now let's do the same thing to y raised to the power 2. If you have y raised to the power 2 and you split it into 2 terms, we can decide to write it like this. Remember, we need to make sure that we split in such a way that we are going to have the factors of minus 12, because the goal of doing this is to factorize. So y squared can be written as 4y squared minus 3y squared. You see? Notice 4 is a factor of 12 and 3 is also a factor of what? 12. So that's a smart way to split the respective terms. So let's now rewrite this as y raised to the power 6. I will no longer be writing minus 2y raised to the power 4. It will now become what? Minus 3y raised to the power 4, as we have here. Minus 3y raised to the power 4 plus y raised to the power 4. And then what about y squared? It's going to be rewritten as what? As we have here, which is what? Plus 4y squared minus 3y squared. Then minus 12 is equal to 0. So we are going to start factorizing in twos. You take these first 2 terms, you factorize. You take these next 2 terms, you factorize. And you take these last 2 terms, and then you factorize. Let's see whether we have a common factor. Okay, so let's factorize. Now, look at this and look at this. What is common? Y raised to the power what? 4. So let's factor that out. Open a bracket. Y raised to the power 4 into y raised to the power 6 is going to give you y raised to the power 2. Because if you multiply them back again, you get y raised to the power 6. Good. So what about y raised to the power 4 into minus 3 y raised to the power 4? That would be what? Minus 3. Sorry. Minus 3, right? Okay, good. So let's come to the second term. Remember, everything we have in the bracket has to be the same. So look at this next 2 terms. What is common? Y raised to the power 2. So if you write y raised to the power 2, open a bracket. What are you going to write here? Y raised to the power 2 plus 4. Oh, we have a little challenge. Look at this bracket. We have y squared minus 3. But here we have y squared plus 4. They are not the same. So we have to do something to this. What are we supposed to do? Now, I'm going to interchange these 2 terms. See, I'm going to interchange 4y raised to the power 2 minus 3y raised to the power 2. I will write minus 3y raised to the power 2 first before 4y raised to the power 2. So that when we factorize, we have similar terms in the bracket. So it's going to be what? Minus 3y raised to the power 2 first, then plus 4y raised to the power 2. Okay, so I am going to erase this and we try again. So what is y raised to the power 2 into y raised to the power 4? You still get the same thing, y raised to the power 2 as we got before. Then the next one, what is y raised to the power 2 or y squared into negative 3y raised to the power 2? Is going to be what? 3. So can you see that what we have in this bracket and this bracket, they are the same thing, which is the goal of this whole thing from time immemorial, if I can say that. So plus, look at this term and look at this term. What is common? 4. So that's 4. And then you have y squared minus 3. 4 goes into minus 12, you have minus 3. All is equal to what? 0. So the good thing here is that we have similar terms in the respective brackets. As you can see, y raised to the power y squared minus 2 here, y squared minus 3 here, y squared minus 3 here, and y squared minus 3 here. Now I'm going to factorize again. We're going to factor these common terms we have in the bracket, this, and this. So let's do that. It's not going to be what? Y squared minus 3 in bracket. And then what you have outside the respective bracket? You have y raised to power 4 here. Then plus what? Y squared. And then plus 4. Okay. Plus 4. All is equal to what? 0. So from zero product rule, since the product of these two factors is equal to 0, what does that mean? It means that y squared minus 3 is equal to 0, or y raised to power 4 plus y raised to power 2 plus 4 is equal to 0. So let's start with the first one. Now if you transpose minus 3 to the right hand side, you are going to have what? Positive 3. Okay, so let's start with this particular one. Recall that y is equal to 3 raised to power x. When we started, we said let y be equal to 3 raised to power x. So if you substitute y for 3 raised to power x, is going to be 3 raised to power x. Remember, y is 3 raised to power x, so you have raised to power 2 here. So I'm going to write 2 here, and all is equal to what? 3. Okay, so remember 3 can be expressed as 3 raised to power 1. So if you multiply x and 2, you have 2x. So that's 3 raised to power 2x is equal to 3 raised to power 1. Since they have a common base, we can equate the exponent. 2x is equal to 1. Divide both sides by 2, x will be equal to what? 1 over 2. So we have gotten one of the values of x that will satisfy the equation. Let's go get the other values of x, and that can be gotten if we use this second one here, which is what? Y raised to power 4 plus y raised to power 2 plus 4 is equal to 0. So let's write it here. Y raised to power 4 plus y raised to power 2 plus 4 is equal to 0. Now watch this. If I want to solve for this, I can rewrite this as if it were a quadratic equation. Now watch this. It's going to be y squared all raised to power 2. Of course, if you multiply 2 and 2, you get 4. So watch this. Then plus y squared plus 4 is equal to 0. So in some way, this is looking like a quadratic equation, although that is if you just pretend as this y squared is not an exponential term. Okay, if you have a quadratic equation of this form, ax squared plus bx plus c is equal to 0. If you have this, how would you solve this using the formula method? It is given as what? X is equal to minus b plus or minus the square root of what? B squared minus 4ac, all divided by what? 2a. So coming here now is going to be what? Since I am using this equation, I'm not going to write y squared in place of what? X. So I'm going to write that y squared is equal to minus b. What is b? Now hold on, let me write something here. A is the coefficient of y squared, b is the coefficient of y squared here, and c is the constant term. So let's rewrite that. Okay, let's just write that a is equal to 1, b is equal to 1, and c is equal to 4. So let's plug it into this. It's going to be what? Minus 1 plus or minus the square root of 1 squared. Remember, b is 1, then minus 4 times what is a? A is 1, and c is what? 4. All divided by what? 2a, which is 2 times 1. So if you take it a step further, y squared will be equal to minus 1 plus or minus the square root of 1 is 1 minus 4 times 1 times 4 is 16, all divided by what? 2. So take it a step further again. Y squared is equal to minus 1 plus or minus 1 minus 16 is minus 15 over 2. Looking at this now, you can tell that this is a complex number. Why? Because you have a negative term in the square root. Hence, we'll say rejected because it is a complex number. Because it is a complex number. So which means we are only going to use the real solution of this equation, which from what we did before, x was equal to what? 1 over 2, and This is the only value of x that satisfies this equation. The other one is a complex number, as we have here. So the value of x that will satisfy the equation is 1/2. Okay, if this video was helpful, kindly subscribe to this channel for more content like this. Do well to share this video to your friends and family, and I'll see you in the next one.